Hello children, so today we'll start another chapter called logarithms. Now from exponentials, from indices chapter, the previous one, we know that 9 is equal to 3 square. 3 square is 3 into 3, so it is 9. Now it can be expressed in another way as log of 9 to the base 3 is equal to 2. So these two are actually equivalent. Now you see 9 is equal to 3 square. So see how to convert it to logarithm. So log of this 9 is actually the exponent of this base 3. Now base of exponential here, this exponential, base of 3 and base of logarithm, it is same. Okay, and logarithm of the number is the exponent of this base. So exponent of this base, exponent is 2. So logarithm of 9 to the base 3 is 2. So you write this as log of 9 to the base 3 is equal to 2. So any exponential number we can convert into logarithmic number, a logarithmic form. Okay, and vice versa, means logarithmic form also you can change back to exponential form. So we try to generalize. Now if a is a real number and it is positive, greater than 0 means positive, and if a to the power n is equal to b, where n is a rational number, n belongs to q means rational number, then we can write then logarithm of b to the base a. Logarithm of b to the base a is equal to n. As we have seen here, logarithm of this number 9 is the exponent of the base. This exponent is the logarithm. So here exponent is n, so logarithm of b is n when the base is a. So you can convert exponential form to logarithmic form. So how do you convert it? So b is equal to a to the power n. So log of b is equal to, it is log of b to the base a is n. So exponent is the logarithm of this number to the base a. Okay. So this is called logarithmic form and this is called exponential form. So you can convert both ways. So you can convert exponential form to logarithmic form, or you can convert logarithmic form to exponential form. Now let's take some more examples, okay, to understand this better, how to convert into logarithmic form. Now we know 2 cube is equal to 8. Okay, so we know if you convert into logarithmic form, log of 8 to the base 2 should be 3. So you see it is log of 8 to the base 2 is equal to 3. Remember, this exponent is the logarithm of this number 8 when the base is 2. Okay. Similarly, another example, 5 to the power 0 is 1. So log of 1 to the base 5, base is 5, is 0. Exponent is the logarithm. So here 2 to the power minus 3 is 1 by 8, because it is 2 to the power minus 3 means it is 1 by 2 cube, so which is 1 by 8. So to convert into logarithmic form, so log of 1 by 8 to the base 2 is equal to minus 3. Okay, so this way you can convert into logarithmic form. Same way, to change it back, suppose you are given this, log of 8 to the base 2 is 3, then 8 will be equal to 2 cube. You can see 8 equal to 2 cube. So you can convert back to exponential form. Now remember some properties here of logarithm. Log of 1 to the base a is equal to 0, because here a to the power 0 is always 1, no matter what the a is. Okay, 2 to the power 0 is also 1, 3 to the power 0 is also 1, 5 to the power 0 is also 1. So logarithm of 1 to any base a is always 0. Okay, now if log of a and the base also, so logarithm of the number and the base are same, so it is 1, because a to the power 1 is equal to a. So log of a to the base a is 1. Okay. So similarly, whenever two logarithms are equal, Okay, you can see if log of x to the base a and log is equal to log of y to the base a. If two logarithms with the same base are equal, then x must be equal to y. Okay, so if x equal to y, then log of x to the base a and log of y to the base a must be equal if bases are same. If bases are different, then the values will be different. Now, logarithms with base 10. Okay, if the base is 10 of any logarithm, it's called common logarithm. Okay, so we'll see later on if the base is e, it's called natural logarithm. Okay, so if the base is 10, it is called common logarithm. So remember, whenever we write log 2, if the base is not mentioned, then the base is 10, it is understood. If the base is not mentioned, then we have to understand that the base is 10. Okay, now let's take some questions to understand it better. So let's take question number 1, part 1. Here, given 5 square equal to 25. Now question says convert to logarithmic form. It's exponential form, so convert into logarithm form. Okay, so this implies, you know, logarithm of 25 to the base 5 is 2, exponent is the logarithm, so we write this as log of 25 to the base 5. Remember, base of log and base of exponential form must be same, is equal to, this exponent is the logarithm. So log of 25 to the base 5 is equal to 2. Okay, this is how we convert into logarithmic form. Now let's take another example, number 2. 7 to the power x is equal to 100. Okay, so this implies again log of 100 to the base 7 is equal to x. So this is answer in logarithmic form. Okay, so log of 100 to the base 7 is equal to x. Remember, exponent is the logarithm of any number. Okay, for the given base. Now, number 3. Let's take question number 3, part 3. 3 to the power minus 2 is equal to 1 by 9. Okay, so number is 1 by 9, so log of 1 by 9 to the base is 3 is equal to minus 2. Remember, logarithm is defined only for positive numbers. Okay, you can find logarithm of a negative number or 0, remember. So log of 1 by 9 to the base 3 is equal to minus 2. Okay, so this is in logarithmic form. So let's take one more so that the concept will be clear. So 81 to the power 3 by 4 is equal to 27. So you have to convert this into logarithmic form. So number is 27. So you write log of 27 and base is 81 is equal to 3 by 4. So logarithm is the exponent. Okay. So this way you can convert into logarithmic form. Now the next question we'll see how we can convert logarithmic form into exponential form. Okay, so this is the reverse process. So question number 2, part 1. So given question is log of 32 the base 2 is equal to 5. So this is in logarithmic form. So we have to convert this into exponential form. Exponential form means in terms of exponent. Okay, so remember here base is 2, so 5. So 2 to the power 5 is equal to 32. So 32 is equal to 2 to the power 5. Okay, so 2 to the power 5 is 32. Okay, base of logarithm and base of exponential must be same. And log of any number is the exponent, so 5 is the exponent. Okay, so this is answer. Now let's take one more example. Number 2. Log of 32 to the base 2 part 2 will take log of 1 by 3 to the base 3 is equal to minus 1. So base is 3, logarithm is minus 1, so 3 to the power minus 1 is equal to 1 by 3. So this is in exponential form. Remember, base we must make same and logarithm of any number is the exponent. So question number 2 part 3. So you are given log of 0.001 to the base 10 is equal to minus 3. So base is 10 here, logarithm is minus 3 equal to 0.001. So this is answer. 10 to the power minus 3 is equal to this. So one more example, part 4. That is log of 1 by a to the base a is equal to minus 1. Same way we take the base first. A, this is power minus 1 equal to 1 by a. So this is answer. Okay, now let's take question number 3. Question number 3. So we have to find the values of this logarithm. So part 1, the question is log of 2, log of 16 to the base 2. Now question says find the value of this log. So to find the value of this, we convert this into exponential form. So what we do is, we suppose first, let log of 16 to the base 2 be equal to x. Now we have to find the value of x, because x is log of 16 to the base 2. So we can find the value of x, so that will be the value of this logarithm. So now convert into exponential form. So 2 to the power x equal to 16, base is 2, so the logarithm is, the exponent number is 16. So now to find the value of x, now we make base on both sides same, so we express this also in exponential form with base 2. So 16 is equal to, 2 to the power 4. Okay, so now since bases are equal, then exponents must be equal, so x is equal to 4. So x equal to 4, but what is x? X is, therefore, what is x equal to? X is log of 16 to the base 2 is equal to 4. So this is the value of log of 16 to the base 2. Now if the base is different, then value will be different. If you see the base is 4, okay, then the log of 16 to the base 4 will be only 2. Okay, because 4 is square equal to 16. Now let's take one more question, that is part 2. Number 3, part 2. Log of 256 to the base 0.5. Okay, so we have to find the value of this logarithm. So once again, let log of 256 to the base 0.5 be equal to x. Now we'll convert this into exponential form. So this implies 0.5, so this is 0, you can write 0.5 to the power x equal to 256. Okay. So you can convert this decimal into fraction, so you get 5 by 10 to the power x equal to 256. So if you cancel here, 2. So 1 by to the power x equal to 256. Now we can take it up as 2 to the power minus x. Okay. So here also now we make the base 2 only. For that we'll factorize 256. See, 256. If you factorize, 2 will go 2 1s are 2, 2 2s are 4, 2 8s are 16, 2 will go 2 6s are 12, 2 4s are, 2 will go 2 3s are 6, 2 2s are, so 2 will go 16 times, 2 will go 8 times, 2 will go 4 times, and 2 will go 2 times. So how many 2s you are getting? 1 2 3 4 5 6 7 8. So that is 2 to the power 8. So when you multiply to 8 times, you get 256. Now since the bases are equal, so their exponents must be equal. So minus x should be equal to 8. This implies x is equal to minus 8. So what is x? X is this. So log of 256 to the base 0.5 is equal to minus 8, and this is answer. Okay.